Hello everyone and welcome back to this session. In this session we will talk about routing. We will discuss the routing tables and routing configuration on the big IP, and we will discuss different scenarios, different requirements. Now let's just note down the virtual server IP address. If you remember, our virtual server was 192.168.100.80. Now we have a requirement that users on the subnet 172.16.1.0 cannot access the virtual server. The virtual server is not accessible for them. Now, if we analyze it, if we try to analyze the default configuration or the default routing configuration of the big IP, during our tests previously, we were testing from a test PC that is sitting on the same subnet of the virtual server. So in fact, with this test PC, we didn't need routing because the test PC had an IP address 192.168.100.15. So it's from the same subnet of the virtual server. Now we're talking about users who are sitting in a different subnet. So the request comes to the virtual server. The virtual server forward the request to node 1, let's say. We have 3 nodes behind the big IP. And then node 1 respond. And now the big IP looks at the packet. The destination IP address is 172.16.1.15, for example. But the default routing table of the big IP is just empty. There is no route. So the big IP will drop the packet. Now, to make this work, to make users in subnet 172.16.1.0 able to use the virtual server and to talk to the virtual server, we have to add a static route on the big IP. We need to tell big IP that if you want to talk to subnet 172.16.1, you will have to go through the next hop 100.2. Let's see that on the GUI, how we configure a static route. To configure a static route, we have to go to network and then click on routes. Click on add, name it subnet 172.16.1, for example. Give it any name you prefer. So the destination is 172.16.1.0. Mask is /24. And the next hop is 92.168.100.2. This is our next hop, which is the router that takes us to this subnet. Click finish. Now, users in subnet 172.16.1 will be able to use the virtual server. Another requirement came that the servers behind the big IP, they need internet access. The big IP itself as well needs internet access. So what type of a route we need on a big IP to tell him, if you want to go to the internet, go this direction. This is what we call a default route. We have to go to the routing table, add default route. The default route usually is 0. Then the destination is all 0. The mask is all 0, means any IP address that we don't know how to reach, we go to 192.168.100.254, which is our next hop for the internet. In this way, the big IP will be able to reach the internet. The servers behind the big IP, they will also be able to go to the internet because we have a default route in the routing table. Let's go to the command line and see the routing table, how to check the routing table using the command line. Let's go to the TMSH mode, show / network route. You can see that this is the static route we created. This is the other static route we created, the default route, which is default destination. All zeros means default. And then we have the outside subnet directly connected to our outside interface, inside subnet directly connected to our inside interface. One note that here is you don't see the management IP address. The management IP address is 0.112. This is the IP address of the big IP appliance. On the TMOS routing table, which we call TMM routing table, you will not see the management interface subnet. If we quit back to the Linux shell and say IP route, this is where you will see the management default route. What is this management default route? When we did configure the big IP, go to platform tab, you see that this is when we first did appliance setup. So the management route will show only in the Linux shell when we say IP route or net stat -r. So you can see in the management routing table, we can see the data routes, TMM routes, and we can see the management routes. We can see the management subnet, the default route that is related to the management routing table. Now, if I go back to the GUI, go back to network routes, you see only the ones that we created. Now, this is a default route, means the way this routing table will work is if we have packet with the destination IP part of this subnet, we send to this next hop. Anything else, any other destination IP address, we send to this. Now, at the same time, we have another default route saying any IP address that we don't know as a destination, any destination IP address that we don't know, send it to 0.254. But you have to know that these are two separate routing tables. This is the TMM routing table, and this is the management routing table. Two different routing tables. Big IP will always prefer the TMM routing table. Big IP will always prefer the TMM routing table. So, in our scenario, when server 1 is trying to talk to an internet destination, maybe we have an IP address 94.1.2.33. This is a public IP. So node 1 is trying to talk to this public IP address. This subnet, this public subnet is currently not in the routing table. There is no route for this subnet. So we assume that it should take the default route it should use the default route. So which default route will it use? The TMM or the management? It will take the TMM routing table. Big IB will always prefer the TMM routing table. Now, another scenario. Now we're troubleshooting the case that currently the big IB is not able to talk to the NTP server. Currently, the big IB is not able to talk to the NTP server. If you try to ping the NTP server, the packet is going up toward the internet router. Why? Because we don't have a route for subnet 22, so that the big IB is using the default route toward the internet. We want the big IB to talk to the NTP server using the management interface. So we have to add a route to the management routing table. We have to add a route to the management routing table. This cannot be achieved on the GUI. This route list, this routing table is the TMM routing table. You cannot add route here and the next hop will be some IP address connected on the management interface. We have to use the CLI, we have to use the command line to create a management or to create a route in the management routing table. We have to go to tmsh, create sys management route, and then we say, give it a name, subnet 22, and then the network is 192.168.22.0/24. The gateway is, as per our topology, should be 0.253. 192.168.0.253. Let's quit tmsh and let's use netstat -r once again. Now you can see that we have a route for subnet.22. Now we can tell that the big IB will be able to synchronize time and to communicate with the NTP server. Now, to put this in context, we have two routing tables. We have the TMM routing table and we have the management routing table. So when the big IB receives a packet and the big IB needs to route the packet, first it will check the more specific routes in the TMM. So step number one, we will check the more specific routes in the TMM table. There is no match for the destination subnet. Okay, we go to the more specific routes in the management. More specific routes in the management. If there is a match, we use it. If there is no match, there is no this particular subnet where the packet is heading to. If it doesn't have any match in the management, then we go back to the default route of the TMM. Only if we don't have default route in the TMM, then we go back to the last one, which is the default route of the management routing table. So the order is more specific routes in the TMM, more specific routes on the management routing table, default route of the TMM, default route of the management table. This is the order. Let's go back and discuss another scenario. Now we have a requirement that we need the big IB to use this DNS server for name resolution. We need the big IB to use this DNS server for name resolution. Do you think with the current routing table, big IB will be able to use the DNS? So if we check the routing table of the big IB currently, this is the routing table, this is the management routing table, and this is the TMM routing table. So if the big IB wants to talk to the DNS, the destination IP address will be 192.168.24.10. Now we have 192.168.24.10. So let's go through the order that we discussed. Do we have a specific route for this subnet 192.168.24 in the TMM routing table? No, we don't. Do we have a specific route for this subnet in the management routing table? Do we have a specific route for this subnet in the management routing table? The answer is no, we don't. The third one, do we have a default route in the TMM? Yes, so we use this. So when the big IB is trying to talk to the DNS server, the traffic is going this direction, is taking the TMM default route. The way to fix this is to add another static route on the management, as we did with the NTP, TMSH, create sys management route, subnet 24, network 192.168.24.0/24, gateway is 192.168.0.254. This way, now we tell the big IB, when you want to talk to subnet 24, go this direction. Now we have in our routing table, we have more specific route for the DNS server. We have a specific route for 192.168.24.0, as you can see it here. Now one more case, which is an interesting case. Let's say, for the sake of this discussion, we have another subnet on the router. Let's say 192.168.48.0. This is the subnet. And we have here management PC with IP address 192.168.48.15. If this management IP address, if this management PC is trying to SSH to the big IB, will it work? Let's analyze the order that we talked about. So the big IP received a packet with the source IP address .15, 48.15, and the big IP need to respond. Now the big IP first will check the TMM routing table. Do we have a specific route for 48, subnet 48? No. Okay. Go to the management. Do we have a specific route for the subnet 48? No. Now we go back to the default route in the TMM. Do we have a default route in the TMM? Yes. The logic says, the logic that we discussed says then the big IP will use the default route of the TMM. But here is an exception. Here is an exception. Any traffic coming toward the big IP on the management interface, the response will only consider the management routing table. Again, any traffic hitting the management interface of the big IP, the response of this traffic will only consider the management routing table. So traffic initiated from a remote peer talking to the management interface, the response of this traffic will go as per the management routing table. That's why this PC will be able to SSH to the big IP. Why? Because when you SSH to the big IP has got a default route on the management routing table to send all traffic for destinations that we don't know, send it to the 254, which is this router. So the PC will send traffic, the big IP will respond, and this PC will be able to manage the big IP using SSH or HTTPS. So the exception says any traffic coming from remote peer on the management interface of the big IP, the response of this traffic will only consider the management routing table. This rule will also apply to the data interfaces. Any traffic coming on data interface, coming from remote peer on the data interface, the response to this traffic will only go through the TMM routing table. Our order that we discussed, TMM more specific routes, management more specific routes, TMM default, then management default. This will apply always to the traffic initiated from the big IP. So as we said, if the big IP is going to talk to the DNS server, so the big IP is initiating a DNS request, we have seen that without having a specific route for subnet 24, the traffic will go toward the internet router. Why? Because it will check more specific route on the TMM, there is no route for this. More specific routes on the management, there is no route for this before we add it. Then it will go to the default route on the TMM, so it will go to the internet. So the rule is more specific routes on the TMM, more specific routes on management, default route TMM, default route management, with the exception that traffic coming from outside hitting the big IP on the management interface, the response will only consider the management routing table. Let's go back to the slides. So as we said, there are two routing tables, Linux routing table, which is used for the management, TMM routing table used for the data interfaces. The TMM routes are always preferred over management route, as we discussed the order. Response for traffic hitting management interface will always use the management routing table, as we discussed. This is the scenario that we're talking about. Traffic initiated from the big IP will go as per the routing table. Rules means, again, traffic initiated from the big IP will go as per the routing table rules. Means more specific routes on the TMM, then more specific routes on the management routing table, then default route on the TMM. If it doesn't exist, default route on the management interface. This is for traffic initiated from the big IP. We have seen how to add static route, and we have seen how to add a management static route. Now, of course, after you add management static route, if you want to delete, you can say delete instead of create.